All right. 75, graphic calculator, office hours. These are the answers. There is work to show. There should be drawings of graphs on most of these. So these are the answers. Pause it if you need to. Okay. Should have checked these already. Anyways, they're available online. And then the back, we did most of it together. We did 10. This is several different. I think we. Anyways, we'll talk about this. Okay, so the first one, you just got to enter everything in. 3/4. Definitely need parentheses. 6 plus 5. Now I would do parentheses 2 to the 1/3, but you got to put parentheses around the 1/3. Otherwise, you need to do 2 to the first and then divide the answer by 3. So parentheses around that, divided by, make sure you close the parentheses. 1 minus e to the third, close. There you go. So round truncated through decimal accuracy comes out the same, 483. Okay, next one, parentheses, sine of 28.4. Now we could be in radio mode and still do this one right by going to second apse angle, degree, close, plus the square root of e, close, divided by natural log of 100, close, plus inverse cosine of 2/3. Now, I don't know if we should assume that's degrees or radians because that does make a difference. So this would be, if this was radians, then the answer would be 0.390. But if we do it in degree mode, we get 0.040 round truncated. So a little bit of debate. Okay, maximum value of this graph, that's upside down parabola. We got a y equals negative x squared plus 5x plus 7. I'm going to do zoom 6 just to start it off with. Negative 10, 10, negative 10, 10. Might change it. It'd be good to probably see the maximum value there. Probably don't need as much over here. So we could say negative 5 and then make the maximum 20. So that looks pretty good. So we're going to sketch that. So I want sketches of any graphs that you graph to help you find these answers. Doesn't have to take a lot of work. Right? This right here is your max. So we're going to let the calculator find it. It happens to also be at the vertex. Sigma calc, max, looks like it's around 2.5, so maybe 1 to 4, I guess 2.5. It is, wow, exactly 2.5. Comma 13.25. Now, the way you're going to write your answer is you're going to say the maximum value of y is 13.25 at x equals 2.5. That's the way I write your answers, max mins. Okay. Next one is the minimum of this graph. So I'm going to go over here. 4x to the third plus 8x squared minus 51x plus 45. We do zoom 6 again. Let's see what happens to cubic. Now cubic should look like that, kind of. You can kind of see, if you know that's what you're going to get, it's very helpful, and you can make more sense of this graph. So I think we want to see some stuff over here. Also, it says 0 to 10, so I think we do want to keep, because the graph keeps going up forever, so there is no, and down forever, so there is no min, there is no max, unless you have endpoints. So endpoints need to be considered. So actually 0 to 10 is over here, but it might be nice to see the whole graph. So let's go window y value 30. Try that. Still not even enough. Window 50. Still not enough. Window 70. I think we got to go up to like 120. Let's try that. Bang! Wow. Okay, let's try 160. I almost got it. Okay, so anyways, it's pretty quick to change the window, but you should be good at that. So I'm going to go ahead and do a sketch of this. The graph goes like this, and then, I don't know, it looks like it might hit the axis, but we're really concerned with 0 to 10 only. So from between these endpoints, and this goes up forever, this looks like it's the minimum point, right? So use second calc, minimum. It looks like, I mean, we could do this. That's left. That's right. Guess. And it is 1.50000005, comma 0. So the minimum value of y is 0.000 at x equals 1.500. For 0 to 10, I guess we should maybe clarify, because the actual minimum of that graph is over here, and there's no minimum because it goes down further. So, okay, the maximal value of this graph. So I'm going to enter this graph in. X squared square root 9 minus x squared, close. Now, if you know anything about this graph, you plug 3 in. If you plug something more than 3 in, or less than -3, it's going to give you an imaginary. So I think if you go, I mean, we could do zoom 6 to start with, but I think the graph's just going to stop, right? Between -3 and, it's going to only be between -3 and 3, because otherwise you get imaginary. Now we can make this graph better by saying like -5 to 5, -1. This is a little better. Probably make the y's a little bigger. 12. There you go. I don't want to see stuff. So that's the graph. So let's sketch it. I need sketches on these. And the graph kind of looks like that. And this is -3 to 3. Okay, so we're looking for the maximum value, which I bet it's here. I bet those are a tie, but we're going to find them both. Second calc, max. There is only possibly one max value, but it can happen at multiple points. So I'd say between -3 and -1. Oh, shoot. So second calc, maximum between -3 and -1. Guess -2. It looks like it's around -2. So this is negative 2.44949, comma 10.392305. So write the stuff on your graph that you find. Second calc, max. This other one, between 1 and 3, guess at 2. And it is at positive 2.4494904, comma 10.392305. So it's same value. So that is the max, and it happens to multiply. So we're going to say the maximal value of y is 10.392 at x equals negative 2.449 and positive 2.449. So you get, it's good to identify all the places where it happens. There you go. Okay, next one, intersections between points and intersections between these curves. So we're going to graph these, x squared minus 7x, which is parabola opening up, and x plus 1 is a line with positive 1 slope. It says negative 10 to 10. I mean, we could do zoom 6 just to start off with, which gives you negative 10 to 10. That'd be nicer to get a little bit bottom of that parabola. So I'm going to go down to negative 15. So let's draw a sketch. And you have a parabola. And you have a line. And so we should get two intersections here and here. So let's use a calculator. So you calculate, intersect, first curve, second curve, guess 0. Seems pretty close. At negative 0.123156, comma 0.8768947. And then the other one, second calculate, number 5 intersect, first curve, second curve. 1, 2, 3, 4, 5, 6, 7, 8. 8.123156, comma 9.123156. So the points of intersection in ordered pairs, negative 0.123, comma 0.876 or 0.877. And the other point was 8.123, comma 9.123. Round or truncate comes out the same. So that's truncated. This would be the only difference if you rounded it. There you go. 3 decimal actually for final answers. Draw graphs, label stuff on the graph. I want to kind of know what your strategy is. Now, these are the same equations. So this could be, where is the parabola below, above or equal to the line? So we could use this graph and say, oh, well, that's this. Okay, and then you'd have your answer. You'd say, oh, okay, well, interval notation is going to be bracket negative 0.123, comma 8.123, bracket. That's your answer. If you hadn't already done that, what I would do is I would move everything to one side. Gradient equals 0, graph a single parabola, and figure out where it's above the x-axis. So real quick, this would probably be the way I would do it if we hadn't already graphed those and found their intersections. Just try and graph its parabola. So let's see. Something like that. It's going to be whatever that is and whatever that is, where this is up. You know what I messed up? It's supposed to be where the parabola is above the line. So that's not even the answer, but it would be negative infinity to negative 0.123 bracket union 8.123 positive infinity. That's the correct answer based off that. And that's going to probably match up to this, hopefully. But those x-intercepts, second calculate 0. Tells you where you got to look for it, -1 to 1, guess 0. Looks like it's 0, but it's not quite 0. Negative 0.1231056, comma 0. And then the other one would be second calculate number 2, 0. 1, 2, 3, 4, 5, 6, 7, 8. It looks like it's around 8, so I'm going to say 7 and 9. Guess 8. And it is 8.1231056. And notice it didn't quite give you 0, it gave you -1, E -12. That's scientific notation. That's it's like 11 zeros before the first decimal number. Anyways, essentially 0. But if we wrote that, we get the same answer. So either way, since we had already graphed it, it was convenient. If we hadn't, I probably would have done it this way. So speaking of that, I'm going to do that on this one because I don't really want to figure out where this crazy graph is above this crazy graph. It's going to be very messy. If I do this, then all I have to do is graph one graph and say where's above the x-axis, which is kind of easy to tell. So absolute value, math, num, ABS, e to the x, close, minus sine x, close, close. We should be in radian mode, okay? So we should be in radian mode. Minus inverse tangent of x plus 2. Window, I don't know, they're telling us -10, 10. We just start with standard. So here's the graph, kind of bumping along. So we don't really, I think we do something better than this. We say, I don't think we need to go all the way down there. So this is a little better view of it, kind of a funny graph. So now it looks like it goes underneath the x-axis. And we can zoom in there and make sure it only goes underneath once. But we want to know, so essentially it's this whole graph except for open dot, except for the part where maybe the one place where it goes below the x-axis. So I think I want to zoom in on there. We can do zoom box if you want to zoom on a very specific location. So create a box. Just to make sure that it only crosses once. Also, with a closer one, oh shoot, you gotta hit enter. Zoom box. Sometimes I accidentally hit the graph button because I think that's what I should do, but you're supposed to enter. So this is what's going on there. It definitely goes below it, and it looks like it just goes once. It's also going to be easier to find those points without them being so close to each other. So second count, 0. Looks like it's between -1 and 0. Guess -0.5. So this is going to be -0.305773 comma 0. So we can calculate 0. The other one looks like it's around 0.5. So 0, left bound, right bound 1, guess 0.5. 0.53140406 comma 0. And so now we should be able to write an answer. So I think it's going to be, now be careful. Some people would say negative infinity to negative 0.305 or negative 0.306 if you want to round. Union 0.531 to positive infinity. This is what some people would write, which could be the answer if it didn't tell you specifically to only consider -10 and 10. So we need to break it off at -10, and that should be a bracket because it is true at -10. And 0.531 comma positive 10 bracket. So this is the answer because of that restriction. If they didn't have that restriction, then you would give that first answer. So you have sketches like this. Number 9, find the slope of the tangent line of y equals x squared, x equals 3. So the tangent line is going to be like this, something like that. I would draw that on there. Now it's just the slope of the tangent line. So so there's a lot of different ways we could do this. I mean, if you wanted to, you could just do it by hand. I guess that misses the point of using your calculator, but this is what it should be, exactly 6. Or let's go ahead and put this equation into our calculator. So it's x squared plus 1. So it's should be a parabola opening up, shifted up 1. We could go window. We could say -4 to 4, -1 to 10. That looks pretty good. Then we could just say second calculate number 6 dy dx. That's a derivative. Add x equals 3. Same answer. Or you could do it from the home screen. Math 8. Vars y vars function y1, comma x, comma 3. Same answer. Or from the graph, you could do second program draw, number 5 tangent line. Add x equals 3. Draws it and gives you the equation down here at the bottom. Y equals 6x minus 8. So I just showed you 4 different ways of doing this. Whatever you pick. The area is going to be this area. So I do need the setup. So the setup's going to be 0 to 3 of x squared plus 1 dx. So I need this. I need parentheses around it. I need the dx. I need the limits. This is the setup. Now you could do it by hand if you want. Antiderivative is x cubed over 3 plus x, 0 to 3, 9 plus 3 minus 0 equals 12. Or we could do it here. So you can calculate number 7. Make sure you're on the correct graph. Upper left corner tells you which graph we're on. 0 to 3. There it is. There's the answer. You could do it from the home screen. Math 9. Vars, y vars, function y1, comma x, comma 0, comma 3. 12. So lots of options. You can write all those notes down. It's up to you. So on the graphing calculator screen, you go second trace, which takes you to the calculate menu. And then you do number 7, f of x dx. And you have to say lower limit x equals 0, and then x equals 3 for upper limit. Or you could go math 9, f and int. You do vars, y vars, function y1, comma x, comma 0, comma 3. That works. For derivative, you know, you do second, trace, calculate, number 6, dy dx, and then you say x equals 3. You hit enter. Or from the home screen, do math 8 in derive, do the whole vars, y vars function, y1, comma x, comma 3. You can do that. You can do the whole drawing the tangent thing. Second, program, takes you to the draw menu. Number 5, tangent. So I don't know. That's all just notes for you. I don't want you to write any of that stuff down for my answers, but for tests or whatever, you don't need to write any of that down. But I do want to sketch. So there you go. We added some notes to the back. We did number 10 together. Number 11, I was encouraging you to do it without actually even trying to do parametrics or use your graphing calculator. So if they say x equals this and y equals this and that, and they say, what's the value of dx dt? Well, x is in terms of t, so dx dt is just the derivative of x with respect to t, which is 1 minus 3 cosine t, right? Then you're saying, where is it greater than or equal to 0? Well, you could use your calculator to do this. I mean, I think, you know, I think this one, well, yeah, I don't think we're going to pull this off. So I'm in regular mode right here, and I'm going to just graph this function and say, where is it above the x-axis? So I'm going to go window 0 to 10. Now this is a cosine curve multiplied by 3, shifted up 1. So I think if we did -3 to 5, that would probably give us a good view of it. So we could sketch this since we're using our calculator to do it. And I mean, we could do a line check, by the way, but you do have a calculator, so we might as well take advantage of it. Where is this graph above or equal to 0? So that's solid dot here, solid dot here, solid dot here. And this is it. So we just got to figure out what those values are. So you can count 0. Looks like there's one around 1.25. So you say 0.5 to 1.5, guess 1.25. So that one's at 1.230959. Second, calculate 0. This one looks like it's at 2, 3, 4, 5. So I'm going to say 4 to 6, guess 5. 5.05222259. Second, calculate 0. That was 5, 6, 7.5. 7 to 8, guess 7.5. 7.514147. So the answer is interval notation, bracket 1.230 or 1.231 if you want to round, comma 5.052 union, bracket 7.514, comma 10. Right? So that's one way to do it. And this one, so I'm not even using parametric mode. I'm not even really thinking about necessarily dy dt. Let's find dy dt by hand. 4 plus 3 sine t. Sorry, the 4 goes away. 3 sine t is greater than or equal to 0. Now this is one we could totally do by hand if you wanted, because divide by 3, when is sine t greater than or equal to 0? Now you could graph it. Y equals 3 sine x. Window is negative 10 to 10. This is a sine graph. It goes from negative 3 to positive 3. So I'm going to go negative 4 to positive 4. So this is what the sketch looks like. It's a regular sine graph. And you want to know, where is it above or equal to? So that's going to be solid dot, solid dot, solid dot, solid dot. And then you use your calculator to find those. But I think those values actually are some pretty nice values. 0. Is there one at, I'm going to go 0 to 1, guess 0.1. You should find 0 if it is 0. 0, 0. Second calc, 0. Looks like there's one around 3. 2 to 4, guess 3. Oh, shoot. Second calc, 0. 2 to 4, guess 3. 3.141597. Second calc, 0. 3, 4, 5, 6, around 6. So maybe 6 to 7, guess 6.5. 6.2831853. And the next one, so I can calculate 0. That was 6, 7, 8, 9. 9 to 10, guess 9.5. 9.424778, comma 0. So I can write my answer now. Where is this graph above or equal to? So it's going to be bracket 0.000 if you want, comma 3.141, 3.142, bracket union bracket 6.283, comma 9.424, or 9.425. So there you go. Otherwise, we could have done it by hand, because this is when is sine equals 0 at 0 plus pi k. And then you could say, all right, let's do a line check. 0 to 10. These are solid dots at 0. Pi is about 3. 2 pi is about 6. 3 pi is about 9. And you can test the value. T equals pi over 2. Sine pi over 2 is 1, which is true. False. False, true, false. If you look, that's what these numbers are. That's 0 to pi. That's 2 pi to 3 pi. Anyways. Okay, I'm going to put something like that on your next test, but you don't even need to use parametric component calculator. Don't even need to really think about parametrics now. These ones we're going to do on our calculator. So we're going to go to mode, parametric, and we're just graphing them and drawing a sketch. Go to Y, go to 31 cosine t minus 7 cosine parentheses 31 t divided by 7. And then the y equals is going to be 31 sine t, close. Oops, I forgot to do that up here. Second, calculate inner, insert, minus 7 sine 31x divided by 7. Go to window. T is going to be 0 to 14 pi. I don't really know what the graph should be. We could say negative 10, 10, negative 10, 10. And we could just try it, see what happens. Oops, something's wrong. Make sure nothing else is on. Nothing else is on. They type it in correct. Looks good. Should be in radian mode. Okay. Window should be -10, 10, -10, 10. And then graph. It's taking a while. I don't know why. Still working on it. Graph ready. Wow. This is crazy. Well, anyways, this was my rough sketch of it. I know that takes a long time. So this is done. So I don't know. I guess these are pretty big values. 31 cosine would be like 31. So maybe the window needs to be like -40 to 40, -40 to 40. We could try that. Oh, there we go. There's something. Okay. It's kind of cool. So, but then it keeps kind of doing that pattern and just kind of starts overlapping it. But we're going all the way like -40 to 40. Ooh, still going. Makes you think of those like things you could draw. I don't know if anyone did that when they were a kid. All the different like kind of spirals. So pretty cool. Next one. Try the same thing. Cosine x plus 0.5 cosine 7t close plus 1/3 sine of 17x close. This one is sine x t plus 0.5 sine 7t close plus 1/3 cosine of 17t. Window is 0 to 2 pi. And then I don't know how big this graph's going to be. I feel like it's not going to be that big. And so we can start -10, 10, -10, 10. That's probably too big, I'm guessing. Because these aren't going to get that big. You get up to like 3. But -5 to 5, -5 to 5 would be even better. You can see something happening. It's actually all right there. So I think we want to go like -3 to 3, -3 to 3. Or even like -2.5 to 2.5, -2.5, 2.5. That's crazy. So kind of makes things the last one, but a lot sharper. So I don't know, you could try and draw that. I sort of drew it like this. But whatever, just something fun. Okay, and 13 says, why is the graph of x equals cosine t, y equals sine t going to be a circle? So this is parametrics. And so here's an interesting thing. Circle would be x squared plus y squared equals r squared, right? Well, let's plug these in. So this would be cosine squared plus sine squared. And what's cosine squared plus sine squared always equal? 1, Pythagorean identity. So there you go. You get a circle. You can try it. See, x equals cosine t sine t sine t sine t. And go window 0 to 2 pi. I think the radius is going to be 1, so we say -2, 2. -2, 2. Graph it, and what do you know? Equation of circle in parametrics. Okay, so that's it.